In our previous lecture, we discussed about what thermal systems are, and of course their classifications. Systems are of three types: open, closed, and of course isolated systems. Now, in this lecture, we will discuss about some other terms that might come across us when we further discuss about this vast field of physics, of thermodynamics, of course. And one particular term is thermal equilibrium and temperature. Now, what is thermal equilibrium? Well, thermal equilibrium can be described as the state of a particular system where it does not exchange heat energy with its surroundings, because the different parts of that particular system are at the same temperature as with the surroundings. Now, we have just described what a thermal equilibrium state of a system is. Another fun term that we have already come across in our daily lives, which relates to the branch of thermodynamics, is the concept of temperature. Now, what is actually temperature? We have predefined thermal equilibrium in such a way that the different parts of that particular system that you are dealing with is in such a state that its different parts are in the same temperature with the environment around it. So we can define temperature as such that it is the particular property of a system that defines whether it will give or receive heat from its surroundings when it is kept in contact with it. Well, it can also be with its surroundings or a particular object that it is in contact with as well. So, alright, we are done describing what temperature is. Well, there are various equipments that help us to measure temperatures, and one of the most common equipments is a thermometer. A thermometer is such an equipment that helps us to measure temperatures of any particular system. For example, if you have a pot where you have hot water, you can just put on a thermometer in contact with that liquid inside the pot to measure the temperature of that water inside. Now, what is exclusive about thermometers and such equipments is that they have a particular thermometric property that allows it to measure temperatures. So what is a thermometric property? Well, thermometric properties of matters are defined as the physical properties of matters that change measurably with temperature, and thus allowing us to measure the change of temperature. So, alright, we are done defining what thermometric properties are. Now, coming to the main equation or the main expression that we are going to derive from today's lecture. We have all learned about different scales of temperatures, and the most famous scales that are in use in our daily lives are Celsius, Fahrenheit, and Kelvin. Now, we will discuss about what can be the general equation that correlates these three different scales from each other and set them apart from each other as well. Well, in order to make a correlation in between these three different scales, we have to take into fact that for every scale the following expression that I am going to write stands true. Now one might ask that what really are these particular terms, lower fixed point and upper fixed point? Well, lower fixed point is that particular temperature at standard pressure where ice actually melts down into water. And of course, for upper fixed point, this is the temperature at a standard pressure when water actually evaporates into vapor. Alright, now moving on to our correlation between the different scales of temperature, Celsius, Fahrenheit and Kelvin, we can say that we know that the lower fixed point for Celsius scale is 0 degrees Celsius and its upper fixed point is 100 degrees Celsius. And for Fahrenheit scale, the upper fixed point is 212 degrees Fahrenheit, and for lower fixed point, it is 32 degrees Fahrenheit. Moving on to Kelvin scale, the upper fixed point is 373 Kelvin, and lower fixed point is 273 Kelvin. Alright, if this really stands, then the particular equation or the expression over here can be defined in such a way that if an arbitrary temperature taken from the Celsius scale is C and the lower fixed point of Celsius scale as defined over here is 0, then it stands as C minus 0, and in the denominator we have the upper fixed point minus the lower fixed point for Celsius scale is 100 minus 0. And as this expression is same for all scales, then we can equate this for Fahrenheit scales and Kelvin scales as well, as by saying that if F is an arbitrary temperature taken from the Fahrenheit scale and the lower fixed point is of course 32 degrees Fahrenheit, divided by the denominator, which says that the difference between the upper fixed scale and the lower fixed point is 212 minus 32, and for the same as Kelvin scale being K minus 273 over 373 minus 273. Then we can generalize this entire thing as being C by 100 is equal to F minus 32 over 180 is equal to K minus 273 over 100. Alright, moving on with further simplifications, we can cancel the zeros out over here, and we are left with C over 10 is equal to F minus 32 over 18 is equal to K minus 273 over 10. Now, we can do some further simplifications by multiplying both sides with 2, and we are left with 5 over here, 9 over here, and 5 again over here. So it stands as C over 5 is F minus 32 over 9 is equal to K minus 273 over 5. So here we go. This is a general expression for the relation between the different scales of temperatures. Well, that's all for today.